Hello, everyone. Thank you for joining us. Welcome to PCB Test Automation and the Smart Factory LinkedIn Live event. My name is Angel Olivares, and I'm in charge of production board sales in several European countries. From our headquarters in the US, we have John Arena, the product line director of our division, presenting today. Please be aware that during this presentation, you can write any questions you might have in the event chat. We will be taking questions during and at the end of the presentation and encourage you to enter them in the chat throughout the session. Now, I'll pass it over to John to get started.
Thank you, Angel. Teradyne is very excited to be part of this LinkedIn Live event. Because of the world situation, we're using more of this forum, and because of the interactive nature of it, it's been very effective. So we do suggest if you have any interest in a question, please do raise it now. I'm going to cover several topics, primarily on the future of PCB test automation and what that means around the smart factory. So very quickly, what does 2021 in the future look like today? The good news is that almost universally around the world, manufacturing is managing very well, even in the conditions of COVID-19. Of course, we're all aware of the sanitization, the spacing requirements, but the world has figured out how to manage this and to deal with their daily lives while also being wise to avoid unnecessary risk. There is a focus on reducing the number of employees. For myself at Teradyne, the factory has been almost empty for over a year now, except for production. So even in the case of production, we look to reduce the number of individuals and the number of interactions. What is driving interest in automation now is COVID, because of the potential to reduce the headcount and the interactions, and also to provide a reliability aspect even with a variable workforce. So with that, I wanted to move into the automation discussion. Many of our customers then raise the question, where do you start? How do I understand how to apply the automation to get these benefits? How do I deal with modern factory requirements like machine-to-machine communication and interconnection to the enterprise so that manufacturing management can see what's going on? And what does Industry 4.0 mean? What does that mean for control, status, and data information? We do see that as a way to future-proof production equipment, that making machines Industry 4.0 capable provides the visibility that manufacturing wants to be able to control and register new requirements for the machines from a remote location. So the current state of PCB automation almost universally is a very automated front end where the surface mount steps occur. And in fact, there may be some inline automation with AOI. But that following this, most commonly we see a back-end process that is constructed of, we say, islands of equipment. You can have a production test island, a flashing island, a functional pre-screen island, and an end-of-line test island. The trouble with islands, or the issue with islands, is that almost universally you're dealing with 2 or 3 different pieces of equipment to manage the productivity requirement. Each of those has some number of operators. And of course you have work in process or buffer inventory between ahead of each of them so that the island can remain productive. The future state of productivity and PCBA manufacturing is to automate more of the front-end process, including the production test and the assembly stages that follow it, so that the entirety of the front end is largely on automation and largely without the need for constant human interaction. The islands become integrated, the function of the islands becomes integrated into the line. This, of course, is managed by line-to-line communication via SMIMA or other protocols, which I'll talk about in a moment. And the other advantage of this is a better line balance. So when you have islands of productivity, each of those works at their own rate. It's very easy to create a bottleneck where one is slower than the other and you have work piling up. With the automated concept, the entire line is optimized for full productivity, guaranteeing more machine utilization, more units per hour. So what I'd like to do is go through some of the observations we have made and some of the questions we receive when we talk to customers about this future vision of automation. The first is that, well, I have work cells, that's true. They work very well. Yeah, there are problems with people and work buffers and so forth. But that becomes very hard to automate. How do I possibly automate a work cell? Well, the first is to realize that there are disadvantages to the work cell. You have the work being divided among multiple groups, and all of them must cooperate to get the units per hour. In addition, work cells are very manual centric. In each of those manual steps, whether it's equipment replacement, tooling replacement, board handling, so forth, barcoding, all of those are done in series, and they all contribute to an increased takt time, the time of the per board, or the cycle time of the transaction. The slower operator has a longer takt time, lower units per hour. So the focus of improving the work cell also goes to improving the overall operator investment in time by removing it. We remove the operator's contribution to takt time and thereby improve productivity. And lastly, pardon me for the phone. Lastly, each of the work cells has a buffer in front to guarantee that product is flowing nicely across each of the work cells. All of that can be eliminated in the automation stage, and that provides the increased units per hour and the increased productivity by assuring that there's no buildup of unprocessed customer equipment at any point in the flow. Here's an example of such an improvement. So here we have a production environment. This is a real example. A customer previously had a work cell of 3 machines, was looking to add an additional machine to improve productivity of the work cell. And by putting a single automation system and the improvements I described earlier, we were able to duplicate the function of 3 testers with still some reserve, eliminate the number of operators, reduce the amount of tooling, and you see the reduction in work cell area. This is a completely automated process, and it continues, the product flow continues into additional automated equipment that follows. By doing all this, we were still able to improve the takt time from a total of almost 90 seconds to 24 seconds. So the automation, the improvements I described earlier, dramatically improve the overall takt time of the process. A common complaint or a common observation is that the work cell processes are manual, and that includes manual documentation, paper, repair tags, and so forth. You know, the manual system is storing test data locally. A printer is producing a kind of work ticket. This ticket is used by the next stage to inform them as to what steps to be done. Yeah, there's some ability to recover that data by the operator, but it's cumbersome. And maybe some ability to report the defect data to the enterprise, but it's often one way. There's no way for the enterprise to then ask for changes in the way MES is recorded. The automated systems handle all of that paper process automatically without any need of the operator to go collect the data or print anything. It's all electronically transferred. All of the data is indexed by barcodes, so the data repair information can be located by simply identifying the barcode of the product. Each of the verbose test results are available, and it can be located anywhere in the factory or the world. So you have automatic asset tracking for the repair process and production steps. These are commonly used functions today that exist without any special handling. Another common complaint is complexity. You know, my product is very complex. It's not really an automation target. Well, in these days, automation can extend well into 6,000 or greater number of test points. You have the ability to use multiple engines or multiple sites to produce even higher units per hour, focused on very short takt time products. And the concept of a test fixture has changed as well. They're far more integrated, far more capable than the test fixtures of even 5 or 10 years ago. Here's an example of such a fixture. In this case, we're looking at a 16-up panel, a combination of ICT, LED test, flashing, and functional pre-screen done on a panel of 16 boards that is processed automatically. You see the fixture on the left is completely open, easy to manage. The wire length is not an issue with modern test equipment. And the integration of all these steps is still achieving the required takt time of the line. We also get the opposite complaint. The products are too small. The volume is not great enough. It's high mix, low volume. It's not really an opportunity to talk about automation. Well, there are other alternatives besides a straight inline solution. 6-axis robots, automated robotics, are easily deployed for board handling. They can address the movement of an irregular product from the whip buffer to the tester and back. Modern testers have built-in robotics control so that the management of the robot, the location of the robot, the control of it is all managed by the tester. And these are, again, fairly common solutions now. We have a video, several videos of this robotics type applications, which we'll be happy to post after this session so you can see the video, which doesn't work very well on a format like this, but you'll be able to see it separately after this LinkedIn Live event closes. The physical size of the product is often a complaint. The product is simply too large, it's too big, it's too wide. It's not uncommon to find automation solutions that can handle products that are 1/2 meter by 1/2 meter or even larger. When you consider that such a fixture is big, of course, but it can also usually be lighter and less weighty than a manual system, because the function of the manual fixture includes a press function, pneumatics or some sort of pressing. That is eliminated with an automated fixture. So the fixtures in that regard can be simplified. And there are several hundred examples of this kind of large board automation in the world today, both from Teradyne and our competitors. So board size is usually not an issue. As I mentioned earlier, there are many solutions in the world today, and the opportunity to pick automation as a component of the solution exists. So these are several vendors that Teradyne is familiar with working with commonly. You see the range from relatively small to relatively large. These are all examples of automation in which multiple kinds of testing, function test, flashing, full in-circuit test can all be performed quite easily, no matter what the product size. So the choice of automation can be optimized for the product, separate from the choice of test, and the two can be merged into a common platform. Looking somewhat closer at the tester on the right of your screen, the larger product there with the Baumann name, this is actually a full multi-cell robotic controlled solution where product comes in on a conveyor. It is taken from the input conveyor. It is processed to one of 6 contacting stations where a variety of testing is processed. So these are 6 different or 4 different or 5 different kinds of value-added processing. And the product is moved from A to B to C as the test flow requires. But all of this is contained within a completely customized work cell that's targeted at this customer's application, all managed by a 6-axis robot at the core.
Sorry, John, I have a question here from one of the people attending.
Yep.
I think it's regarding the previous slide we saw. I see several interesting pictures of different integrations, but most of them are considering a linear movement of the PCB. Would it be possible to integrate a Teradyne tester with our own automation solution, for example, a robotic cell or a round table automation?
Yes, we've done both of those examples previously. So integration of a test solution with a third-party automation solution is commonly done. And in some cases, we've managed to integrate a test solution into the customer's automation. Because our test solution is flexible, we have the ability to duplicate entirely the function performed by the earlier test engine and reusing the customer's automation. There are many questions that should be asked in this case, but it's always a possibility to consider.
Following this question, there is something, it's related. Is it possible for Teradyne to upgrade existing obsolete test solutions that are integrated in an automation solution without replacing the whole automation solution or having to rebuild all features? I think here they are referring to existing automation using other ICT suppliers that maybe are out of the market or they want to change for some reason, and customers are interested to reuse all the investment in features.
Yeah, I did not bring slides to discuss this particularly, but usually that is the case for an older machine, an older test solution that is obsolete or not doing not as productive as it should be. The Teradyne solution is extremely small. It can fit into just about every piece of automation, and because it is a full in-circuit test, it can usually duplicate entirely the testing function of earlier generation test solutions, no matter what the brand. So we have done this a couple of times now. This preserves the fixture. It preserves the test flow in the program. We will usually regenerate the program and match the test flow, but it's quite easy to do. Okay. Another question we get commonly is, how do I connect my automation solution to the enterprise? The work cell is hard enough to connect. How do I possibly connect the automation? Well, if you have a work cell based solution, you realize you're dealing with, as I said earlier, usually a printer output or maybe a local kind of data log file that has to be post-processed to connect to the enterprise. These post-processing tools are not standard. They must be developed. There's generally not a way to connect the work cell to other machines in the line for machine-to-machine communication. There's very little real-time control usually available, and there's no way to record the calibration or maintenance state of the manual system in an automated way. The modern automation systems have built-in capability to communicate the control, allow control of the machine, communicate the status of the machine, or to report the test results or calibration results. It's natural for the automated machine to provide this data because we don't have an operator standing by. So all of this capability is produced for the enterprise to monitor. These are usually available as standard plugins or even product that we have on the shelf. You have the ability to monitor temperature, hours of operation, calibration status, anywhere in the enterprise. And this is real-time information that is produced second by second on the machine. One example of that is a product that we are rolling out now. We call it Smart 4 Metrics. Here we have a way to connect all of the machines on the floor via both an operator interface to interrogate the machine for its current state, its current calibration, its current production status, as well as connect real-time those machines to implement machine-to-machine communication. So we have both a real-time interface and the web interface for the operator to provide that functionality. And these are developed to work with almost any existing connection on the line. We use a series of standard tools that we've developed as well as plugins that can be developed for proprietary interfaces. In this way, the machine is made to be completely in control of the factory and completely aware to the enterprise.
Sorry, John, I have another question here.
Yes.
Does Teradyne already have a solution to integrate the software with MES systems like ITAC, SAP, or new standards like IPC-CFX?
Yeah, good question. So ITAC and other MES standards, historical standards, have for a long time been supported by custom solutions. Teradyne is still supporting these, but for new functions like IPC-CFX or Hermes, we are moving to this kind of plug-in concept where we have a standard interface on the testers, a series of plugins that are pre-written that integrate the tester to the desired MES system. So it's not a problem at all. There are some other considerations of automation that are important for work cell users to understand. When you talk about conveyorized handling, you're talking about the moving of something that has mass and something that has size. And so the program development and the deployment into production needs to comprehend that this dynamic movement is something to be measured and analyzed and reflected in the test program. So the motion parameters, the size, the speed of the conveyor, the stopping point of the conveyor, are usually part of the test program development, and they're stored based on the tooling ID. Each tooling has its own identification. When that tooling ID is registered with the machine, the historical motion parameters are recalled. So you have this way to assure that the dynamic performance of the machine is matched to the product being tested. The product weight and the outline must also be considered. Obviously, heavy products require additional time to transit from moving position to stop position, and that's something we call slowdown. That slowdown time is part of the development to analyze the product weight and the product slowdown performance. So that is also part of the development process. And lastly, we always think about PCBAs as being rectangular, but in many cases they are not. So the performance of an irregular or non-square, non-rectangular PCBA must be understood both from a motion point of view as well as the stopping point of view. We want to be able to stop that PCBA exactly in the same place every time. That requires that we understand the point of contact and the dynamic performance of that irregular PCBA as it comes in contact with the stopper position.
John, I have another question related to the automated systems here. Mm-hmm. What about the maintainability of these automated systems? We have experienced that maintaining integrated solutions cause a longer downtimes due to the relatively bad access to its integrated components.
That's a great question. So many of the test equipments developed today were produced years ago, decades ago, and they were not designed for automation. Our modern solutions from Teradyne are designed for easy maintenance. So even if it's in third-party automation, Teradyne always adheres to one principle on maintenance. It should be quick and it should be accessed without special tooling. So whether it's any of these vendors, by accessing the front and the back covers only, a card can usually be replaced in a few minutes' time, or a power supply in a few minutes' time. Without any special tooling, without any requirement to remove the test head from the automation. This is not possible with machines that are designed decades ago, that were designed around a different maintenance principle. So we always focus on maintainability. Even though the machines are extremely reliable, there are cases where in production environments you do see a defect, maybe 1-2 a year. Then you should have very quick time to return to service. So we want to be able to identify the defect, remove the defective component, and then restore the machine to service. All of that is a focus of our test engines, no matter what the automation solution. One of the concerns, or one of the features of modern equipment, is the ability to demonstrate test stability. So particularly, Angel, you asked a question earlier. One of the listeners raised a question about taking an earlier generation machine and trying to preserve the tooling and preserve the test flow. One of the biggest problems with such a solution, such a concept, is how do I verify that this new program is doing exactly what the old one did and that it is stable? So modern solutions, particularly Teradyne, have a way to demonstrate for each component, each test, the stability of the measurement. So here we have, a test flow showing on the left the actual component flow, and on the right, the consequence of measurements taken of one component over multiple tests. So we can demonstrate that in this setup, all of the measurements are within the high and low thresholds set automatically by the test program generation, so that we know the machine is stable. So when you do a rehost or a conversion from prior generation to a new generation solution, you have confidence that the test is stable and repeatable. Lastly, I spoke very early in today about the concept of operator systems having, manual systems having operator components to takt time. Operators barcoding, operators handling, all of that has to happen before testing starts. Automation has a solution for handling this even more efficiently. Rather than take these processes like barcoding or pre-processing or reporting test results in series, we use a technique called pre and post processing, where we're testing board A, but we're testing board A-1. We're doing a pretest on A-1 to look for barcode, MES, MAC address. All of that pre-processing is done in parallel with the test of board A, and then board A+1. The reporting of the test results is done in parallel with the testing of A. So instead of pre and post test process adding to takt time, it is done at the same time so that it does not contribute to additional takt time. These are tricks, these are methods that are used in automation, and they're part of the test program development to help optimize the overall takt time to fit within the line cycle rate.
John, I see another question. Is it possible to use this pre-test and post-test option in an existing Teradyne offline tester?
It is possible to do the pre-test and post-test processing. So in this case, the operator would be testing board A, but A-1, the next board, he's doing some pre-test processing on. The tools exist. The question is always the stability of the operator, because now you have 2 or 3 boards the operator is handling at the same time. The next board, the last board. So you have the opportunity for confusion. So technically, it's not an issue. The issue is really the stability and reliability of the operator to understand what he is doing. And that is really the challenge.
Yeah, maybe using a cobot could solve this problem.
Yes, yep. That is the presentation for today. Our goal is really to expose the listeners to some common questions about automation and common answers to these kinds of questions that have been developed for earlier applications. We welcome your questions either today or separately by the link here on the screen. Angel, are there any other pending questions you have?
I don't see any other questions. If you have anything you would like to ask, you can post here on LinkedIn or contact me through the email on your screen. And don't forget to check out the automation videos mentioned earlier using the link on the event page following the session. Thanks for joining us. Have a good afternoon or good day if you are in Americas, Mexico. It's a lot of attendees from the part, and hope to see you very soon face to face. Bye.